If the residual plot has a pattern such as a curved or U-shaped appearance, you can then transform the LSRL. It is important to note that transforming the LSRL or using a different non-linear regression model should be based on the pattern observed in the residual plot. Transformations should not be applied blindly without careful consideration of the model assumptions and limitations. Furthermore, any transformation or modification to the model should be validated to ensure that the new model is a better fit for the data than the original model. Defining terms. The y refers to the observed values of y in the dataset. The hat part of y refers to the predicted values of y, and A is known as the y-intercept, B is known as the slope of the LSRL, and X is the explanatory value, also known as the independent variable, and it always belongs on the x-axis.
Some word problems, no transformations may be needed. For example, if the residual plot is scattered. If the residual plot is scattered, the LSRL is a good fit for the data. In these cases, a simple linear regression model of the form y hat is equal to a plus bx would be appropriate.
Sometimes the relationship between two variables is not a straight line, and a curved line may fit the data better. In such cases, we can use a transformation to convert the curved line into a straight line, which is easier to analyze. One such transformation is taking the square root of the dependent variable. Once we have transformed the data, we can fit the straight line into the transform values and obtain the LSRL. We can then use this equation to make predictions about the data.
Sometimes, when we look at data, we see that the relationship between two things is not a straight line, but rather it grows or decays more quickly over time. In this case, we can take the log of x and the log of y hat. The log transformation can also help reduce the influence of extreme values. However, we should be more careful when applying this transformation and make sure that it is appropriate for the data and the problem we are trying to solve.
By taking the reciprocal of y hat, we can make the relationship between the two variables linear. When we take the reciprocal of y hat, we are essentially reversing the values of y hat. For example, if y hat was 2, its reciprocal would be half. If y hat was 1/3, its reciprocal would be 3. It may be the best transformation to use when we have a non-linear relationship between variables and we want to transform it into a linear one. Take the log of y hat to transform the LSRL. Take the values of y hat and multiply them by log. Logarithmic transformation can be useful when the relationship between variables is not inverse, but rather follows a curved pattern, such as exponential or power functions. By transforming the y hat values using logarithms, we can straighten out the curve and make it easier to fit a linear model.
Alright, so in this problem we're going to determine what type of transformation we need. So penicillin was administered orally, and the concentration of penicillin in the blood was determined after 5 different heights of time. Predict the penicillin of concentration for 5 hours of elapsed time. First, we're going to plot the x and y values, and then put them into L1 and L2. Next, we're going to create the residual plot to see if the LSRL is a good fit. Since the residual plot shows a pattern, it represents that the LSRL is not the best fit for the data. Next, we're going ahead and use StatCalc 8 linear regression to figure out the LSRL. Now, since there is a problem, we're going to apply log of x and log of y to all the x and y values. Now we can see the new residual plot, and since there is no pattern, we can determine that the LSRL is best fit.